Betelgeuse, one of the biggest and brightest stars we've ever seen. It's both gorgeous and dangerous in a way you can't even imagine. This star is old, bloated, and unstable, like me. It can go supernova at any moment. And it hides a mystery our astronomers haven't managed to crack yet. Will it impact the future of our planet? Well, let's see. Betelgeuse is the bright red shoulder of Orion, the hunter in the sky. It's a red supergiant star, and by supergiant, I mean really giant. This star weighs somewhere between 15 and 20 suns, but it's so stretched out that if you dropped it in our solar system, it would reach all the way to Mars. Imagine our planet swallowed by a glowing, bloated ball of reddish fire. No thanks. As for the whole red giant thing, it means a star near the end of its life. When it runs out of hydrogen in its core, it starts burning hydrogen in a shell around it. This makes the star's outer layers puff up and cool down, so it looks much bigger, cooler, and red in color. Betelgeuse isn't exactly in peak health. Massive stars like this live fast and pass away while still young. Their lifetimes depend on a lot of factors: mass, spin, how much metal they've cooked up in their cores. But even on the generous side, they only last a few million years. On the tight side, maybe a few 100,000. For comparison, our 4.6 billion-year-old Sun has plenty of life left. And tiny red dwarfs can keep going for trillions of years. Trillions! The universe itself isn't even old enough for red dwarfs to start kicking the bucket. Betelgeuse has already burned through all of its hydrogen, and now it's running on helium. That's what made it swell up into a red giant in the first place. Back in 2019, the star suddenly dimmed so much it looked like it was about to explode. Astronomers around the world were super excited. They thought we were about to witness a supernova in real time. But the truth was far less dramatic. Betelgeuse didn't reach the end of its cosmic life. It had just coughed up giant clouds of dust and gas, which drifted in front of it and blocked the light. Later, astronomers seemed to figure out the reason for this thing. The star basically blew off a huge chunk of its own atmosphere into space. And it was massive. The chunk had several times the mass of our Moon, and that's about 400 billion times more material than our Sun throws out in one of its normal eruptions. Once that piece cooled down, it turned into a giant dust cloud. From Earth, that cloud blocked a lot of Betelgeuse's light, making it look like the star was fading. But that's not all. Betelgeuse usually has a steady rhythm. It gets brighter and dimmer every 400 days, almost like a heartbeat. After this outburst, that cycle seems to have stopped, or at least gone quiet for now. When a star is old and unstable, its life might become pure chaos. One moment it's burning hydrogen, the next helium. Sometimes it shuts down. The next day it roars back to life. Its outer layers are so stretched out that they almost seem to be independent and have a mind of their own. Plus, there are terrible secrets these stars can hide, and Betelgeuse has one of its own. For decades, astronomers suspected Betelgeuse might have a hidden companion star, but spotting it was nearly impossible. Why? Because Betelgeuse shines up to 14,000 times brighter than our Sun. Its glow basically drowns out anything nearby. On top of that, our planet's thick atmosphere makes stargazing tricky. Light from space gets blurred and distorted as it fights its way through the air. When the Great Dimming happened in 2019, the Hubble Space Telescope was able to watch it unfold from above the Earth's atmosphere. It managed to clear up fears that Betelgeuse was about to explode, but even Hubble couldn't see through the massive cloud of gas and dust the star had coughed out to check for a potential companion. That's when astrophysicist Steve Howell from NASA's Ames Research Center tried a different approach. He turned to the Gemini North Telescope on Mauna Kea in Hawaii. It's a massive ground-based observatory with a wide opening that lets in more light. Gemini's secret weapon is a high-resolution camera called the Alopiki Speckle Imager. Instead of taking one long exposure shot, It fires off thousands of ultra-short ones. It helps freeze the chaos caused by Earth's atmosphere. Later, computers stitch all those snapshots together, scrubbing away the turbulence and leaving behind crystal-clear images. So, Steve Howell and his team got down to work, convinced something had to be there, something that had slipped through all the earlier searches. With the Alopiki camera, they finally had the tool sharp enough to catch it, if it really existed. Howell later admitted the odds were slim. And still, Howell's team finally caught what looks like a faint companion star hiding at the far edge of Betelgeuse's atmosphere. And the best part was that it showed up exactly where earlier astronomers had predicted it might be. Same spot, same distance, and even the same angle. It wasn't just a random flicker of light. It matched the map. Right now, the companion is still hiding too close to Betelgeuse's blinding glare to see clearly. But its orbit will eventually carry it farther out, away from the giant star's brightness. That moment will come in November 2027, and when it does, telescopes should finally get a clean look. Those follow-up observations will settle the question for good. Is this faint little star real, or just a data glitch? Oh, by the way, the companion star already has a name. Betelgeuse comes from Arabic and means the hand of Al-Jaza, a legendary figure drawn across the night sky by ancient stargazers. They saw her whole form, hands, feet, head, hair, all stitched together by the stars of Orion. So Howell thought it only fitting to continue the theme. He named the companion Sawara, which translates to her bracelet. One day, long into the future, Betelgeuse and Sawara will spiral together and merge. But with a companion star or not, Betelgeuse is old, tired, and basically running out of gas. The clock is ticking, and one day, sooner or later, it'll go supernova. And when it does, it'll be a cosmic fireworks show unlike anything we've ever seen. Based on what we know, its size, how fast it spins, the group of stars it was born with, and the metals in its atmosphere, astronomers guess that Betelgeuse could explode as a supernova in a few 100,000 years. But don't get too comfortable, it could happen tomorrow. Or maybe it already did. Remember, the star is 500 light-years away. That means the light we're seeing now left Betelgeuse many, many years ago. If it exploded a century ago, we wouldn't know it yet. The star might already be gone. But when we finally see it go supernova, it'll be a show like nothing else in human history. A supernova can outshine entire galaxies, and at this distance, Betelgeuse will be blinding. It could be visible even during the day, brighter than any planet and nearly as bright as the full moon. But unlike the full moon, it won't be a comfortable glowing disk. Betelgeuse will remain a tiny pinpoint in the sky, but staring at it might actually hurt your eyes. This brilliance will last for a few months before fading, as all supernovae do. And don't worry, it won't hurt us. Why? Well, as crazy as a supernova is, stars are really far apart. That's where the inverse square law comes in. The energy a star or supernova emits spreads out over space. Double the distance, and the energy per spot drops to a quarter. 10 times the distance, and you're only getting 1/100th of the energy. It's the same reason you can walk a few steps back from a campfire and go from roasting to freezing in seconds. Anyway, what happens next is out of our hands. Maybe Betelgeuse will keep wobbling along for thousands of years. Or maybe tomorrow night it'll light up the sky like never before. Either way, the universe has a way of surprising us, and the future will show what this giant star has in store.
An ultra-powerful explosion happened just outside the Milky Way galaxy, kinda next door in cosmic terms, and it was unlike anything we've witnessed before. The thing kept blasting again and again, shooting out crazy strong bursts of energy called gamma rays. It was almost an entire day of non-stop firing back in July 2025. In gamma ray time, that's basically forever, because normally gamma ray bursts last from a few milliseconds to a few minutes, not hours on end. But the craziest thing is that this phenomenon might be linked to an elusive and mysterious kind of black hole, the existence of which we haven't proven yet. Scientists gave this phenomenon a complex sciencey name. Usually, these gamma-ray bursts happen when a giant star goes off. One big dramatic exit, and that's it. But this space diva didn't get the memo and kept coming back for encores. NASA's Fermi telescope first spotted this bizarre space performance on July 2nd. But then some other space gear, the Einstein probe, realized it had already been blasting the day before. Scientists tossed around a few guesses. It could have been a massive star, like 40 times the size of our Sun, that went out in a special kind of way. Not your average star demise, but one that somehow kept its cosmic engine running, like a car that won't stop even after the gas runs out. Another theory is even wilder. Some scientists think those space fireworks might have gone off when a star, likely a tiny one called a white dwarf, got shredded by a black hole. It's like a cosmic blender moment. They call it a tidal disruption event, or TDE. You see, not every star goes out with a giant boom like in the movies. Most just get old, puff up, and slowly fade away, leaving behind their tired little cores. Those leftovers are called white dwarfs, star corpses made of super weird squished up gas. You see, what happens to a star when it goes off depends on how big it was when it was born. Stars that start out kind of small, about the same size as the Sun or up to 10 times bigger, usually end up as white dwarfs. Most of the time, these stars run out of fuel and blow off their outer layers, creating a glowing cloud called a planetary nebula. What's left behind is the super hot dense core, about the size of Earth. That's the white dwarf. They're still really hot when they form and slowly cool down over time. After billions of years, they might turn into cold, dark, black dwarfs. But the universe isn't old enough for any of those to exist yet. Anyway, let's get back to our investigation. If this second theory is right, the black hole responsible for this cosmic show wasn't a regular one. To pull off something like this, it would need to be a super rare kind of black hole. One of those mysterious intermediate mass black holes scientists have been trying to find forever. Before we move further, let's take a look at the black hole lineup. Small ones are called stellar mass black holes. They're formed when massive stars weighing somewhere between 20 to 100 suns collapse. Supermassive black holes are real space behemoths. They're millions and even billions of times heavier than the Sun. They chill at the centers of galaxies. Even our home Milky Way galaxy has one called Sagittarius A star. This black hole is mostly dormant. It absorbs gas or dust only occasionally, but its estimated mass is millions of times that of our Sun. There might be one more type of black hole, primordial black holes. Scientists think they might have formed in the very first moments after the birth of the universe. That's when pockets of hot material could be dense enough to form black holes. Their masses might have ranged from 100,000 times less than a paperclip to 100,000 times more than that of the Sun. After that, the universe expanded and cooled very fast, and the conditions for forming black holes this way came to an end. These days, 13.8 billion years later, astronomers still haven't found definitive proof that those primordial black holes even existed. On the other hand, it's possible that they could have evaporated as space became older, due to certain processes happening at the edges of their event horizons, aka the points of no return. According to theoretical predictions, lower mass black holes with less mass than a mountain could evaporate more quickly than larger ones. If this idea is correct, then many of those early black holes have already completely dissipated. But more massive primordial black holes could still be lingering across the universe. Anyway, if we get back to the already proven kinds of black holes, between stellar-sized black holes and supermassive ones, there are elusive intermediate mass black holes. Scientists think they exist, but they're like Bigfoot. Lots of theories, not much proof. Astronomers think that small black holes might crash into each other and merge over time to form those medium ones, but spotting one is almost impossible. They're sneaky and silent. People often tend to mistake them for star graveyards, clusters of smaller black holes just hanging out. Sometimes, intermediate mass black holes even hide behind groups of stars that orbit them real close. The best way to catch such a black hole is to look for clues. Scientists measure the mass of black holes when they crash into each other, or spot them mid-meal when they're munching on a nearby star. So far, around 300 possible intermediate mass black holes have been found, but no one is totally sure which ones are the real deal. And now, astronomers think they've finally caught this super rare missing link black hole. Right now, it might be snacking on a poor star way out at the edge of some distant galaxy. In a study published on April 11, 2025, scientists talk about a black hole called HLX-1. It's hanging out about 40,000 light-years from the center of its galaxy and roughly 450 million light-years away from us. Using data from NASA's Hubble Space Telescope and the Chandra X-ray Observatory, the team spotted a bright flash, that very tidal disruption event that occurs when a black hole tears a nearby star to pieces. Then they ran computer simulations to recreate the whole thing, and it showed HLX-1 stretching the poor star like space spaghetti. By the way, this process is indeed called spaghettification. Astronomers have their own cosmic jokes, you know? Anyway, scientists first spotted something weird going on with HLX-1 back in 2009. NASA's Chandra X-ray Observatory caught a super bright glow coming from deep space. Turns out, it could have been another tidal disruption event. The glow from HLX-1 hits its peak around 2012, and it's been fading ever since. But of course, there's a catch. Nobody's totally sure it's a real intermediate mass black hole. You see, that light might not be from a shredded star at all. It could be from an accretion disk, a giant, super hot ring of gas and dust swirling around the black hole's edges. And the only way to figure out what's really going on is to keep watching. If the light keeps fading and doesn't flare back up, then yeah, that poor star probably got eaten. Intermediate mass black holes are a big deal because they're the missing link in the black hole family tree. The connect the dots piece in understanding how black holes grow up. There's also an idea that intermediate mass black holes might start out as big stellar mass black holes and just keep bulking up over billions of years until they become those massive, city-sized monsters at galaxy centers. That means most of their lives, they're probably lurking way out on the galaxy's edge. Like HLX-1, before they get launched into deep space. And now, some scientists think there could be a sneaky intermediate mass black hole hanging out on the outskirts of our Milky Way right at this moment. Even if there isn't, the research team is still keeping an eye on what's happening after that blast and trying to piece together what in the universe actually caused it. Next up on their to-do list is figuring out exactly where it happened. Once they pin down the location, they'll be able to measure just how much cosmic energy this thing pumped out and how big the explosion really was.
Imagine you're looking up at the sky on a clear night and you see all those beautiful stars twinkling up there. Well, one of them is Betelgeuse, a celebrity among stars. If you want to catch a glimpse of it, look up at the Orion constellation. It low-key looks like an archer holding a bow, and you can spot Betelgeuse as the reddish-orange dot on their shoulder. It's one of the brightest stars in the sky, so it's hard to miss. Betelgeuse is not your ordinary star. First of all, it's gigantic, up to 1,000 times the size of our Sun. Can you imagine that? It's so enormous that if we could somehow replace our Sun with Betelgeuse, it would engulf all the inner planets, including Earth. And here's another fun fact. When we look at Betelgeuse, we're actually looking back in time. Yep, you heard it right. Betelgeuse is about 600 light-years away from us, so the light we see today actually left the star 600 years ago. It has quite a history. This star has been shining brightly for millions of years. Long, long ago, even before smartphones and telescopes, ancient Sumerians were the first to spot Betelgeuse in the sky. And it's been a diva this entire time. For example, in 1866, Betelgeuse became one of the brightest stars in the night sky. It was so dazzling that people could see it even during the day. Astronomers all around the world went bananas documenting this extraordinary event. Since then, Betelgeuse has been playing hide and seek with us. It all started when Betelgeuse started to dim back in 2019. Since then, it likes to dim and brighten sporadically. But these changes in brightness tell us about something important. As we mentioned, Betelgeuse was always a bit of a troublemaker. It's been living a fast and furious life. Because of that, it has been burning its fuel at an incredibly fast rate. The changes in the star's brightness are clues that Betelgeuse is approaching the end of its life cycle. The drama intensified when the Hubble Space Telescope snapped jaw-dropping images of Betelgeuse, like it was getting ready to blow its top. All this made scientists think that the star is close to retiring in a dramatic way. It's about to go supernova. So, picture a star partying hard, powered by the fusion of hydrogen atoms. It's like the star's own energy drink. But just like any party, the fuel starts to run out. That's when things get interesting. As the star guzzles up its hydrogen fuel, it slowly begins to run on empty. It can't sustain itself anymore. So now, it's time for the grand finale. This finale is called supernova. The star collapses in on itself like a deflating balloon. The pressure and temperature inside skyrocket to mind-blowing levels, and this celestial tantrum triggers a colossal bang. So, you can see why observing Betelgeuse is like having a front row seat to the spectacular drama. But here's the big question: when will this happen? Well, the answer is not as simple as setting a timer. You see, stars have their own schedules, and Betelgeuse is no different. It could be tomorrow, or it could be thousands of years from now. Scientists have come up with only a rough estimate. They believe that Betelgeuse will go supernova within the next 100,000 years. Quite a spread, huh? Sure, that sounds like forever to us tiny humans, but in the vastness of the universe, it's just a blink of an eye. But there's a chance, just a tiny chance, that Betelgeuse could surprise us all and go supernova much sooner. Considering its dips in brightness, we might be in for a show within the next few hundred years. We'll just have to wait and see. Now, if Betelgeuse does go kaboom, what will happen? Well, get ready for a show like no other, folks. When a star collapses under its own weight, it unleashes a cosmic firework of epic proportions. The star releases a crazy amount of energy in the form of light and heat. Betelgeuse's supernova is going to be extra special. It's like the superstar of supernova. It will shine so brightly that it might even outshine the other stars in the sky. Picture that. Betelgeuse stealing the spotlight. This show could be so bright that you won't need a telescope to catch a glimpse. Nope, you'll be able to see it with a naked eye. It might even be visible during the day, making the sky look like it's hosting the coolest rave ever. After that, the supernova will keep us entertained for weeks. It will be like having a second moon in the sky, shining as bright as the full thing. Imagine that. Two moons dancing together in the night. After several weeks of lighting up the night sky, Betelgeuse's supernova will slowly fade away, but it would leave behind a souvenir, an ethereal remnant. It's like a fading memory of the star's epic performance. This remnant, too, would slowly fade away over the course of several months. But it's not just about the light show. The boom will send out powerful shockwaves, and we might actually feel them right here on Earth. It's like the universe giving us a gentle tap on the shoulder saying, "Hey, look at this amazing spectacle." How dangerous will it be for us? Well, we know that Betelgeuse's supernova would send dust and gas shooting into the atmosphere. It's like a big space sneeze. And this sneeze could cause a decrease in global temperatures. We're talking serious climate impact here. It could even lead to a mini ice age. But these are just assumptions. We don't know for sure if the consequences will really be that serious, but of course, we want to be prepared for this event just in case. That's why scientists are studying Betelgeuse closely. But in addition to serious scientific research, astronomers also have a blast of celestial comedy. Jokes are flying left and right. Someone has even created a Betelgeuse status account, which you can check yourself. So, as you can see, the star is keeping us on our toes. Astronomers keep observing it, and they need our help too. They want us to keep an eye on Betelgeuse and report any changes we see. How do you do that? First off, channel your inner astronomer and observe Betelgeuse. Take a peek at the star and note down what you see. Is it twinkling, shining, or feeling a bit dim? Jot it all down. Then, be a superstar yourself and report your observations to the astronomers. Your observations will help them track Betelgeuse's journey towards its big supernova moment. You can also join in on some citizen science projects. They're super fun and easy, trust me. One cool project you can jump into is the Betelgeuse Brightness Monitor. By participating, you help scientists keep tabs on how bright Betelgeuse is shining. Your contribution can make a real difference. So, join the monitoring team. You'll be part of something amazing, and who knows, your observations might even help predict when Betelgeuse will show off its supernova magic. By doing that, we can assist them in monitoring this superstar and learn more about the fascinating world of stars. But that's how we can help scientists to predict this event. Now, how can you personally prepare for it? First things first, you'll need the right gear to catch all the supernova action. A trusty telescope is like your front row ticket to the starry show. It'll bring you up close and personal with Betelgeuse's performance. And remember, you'll need special eyewear to shield your eyes from the intense burst of light. Safety first, and of course prepare in case it decides to mess with our climate. Stock up on essentials, like warm clothes and supplies, just in case we experience a mini ice age. But let's just hope it won't happen. So, keep your eyes on the night sky, my friends. Betelgeuse may not be ready to blow up just yet, but when it does, it will be a sight to behold. Until then, let's enjoy the twinkling stars, and remember, there's always something extraordinary happening in the vastness of space.
So this year, before September, a star in the constellation of Coronae Borealis will explode, and in the northern hemisphere, we'll be able to see it with the unaided eye. This star is T Coronae Borealis, a white dwarf star 3,000 light-years away from our solar system. It will turn into a nova, which we'll discuss a bit later, in spring or summer. Even though this occurrence is predictable, happening every 80 years, it's still a once-in-a-lifetime event, if you're human. T Coronae Borealis is not your regular star. It's actually a binary, two stars orbiting each other. This pair, though, is incredibly special. Occasionally, the stars increase their brightness to such an extent that they become visible on Earth. The white dwarf star is the more massive one of the two. But the most shocking thing about it is that it might pack the same mass as the Sun into a volume only as large as Earth. The companion star, an aging red giant, has already expanded so much that it's dumping its material onto the white dwarf. So it's time for another explosion for these two. It's going to take the star's brightness from magnitude 11 to magnitude 2. You see, in astronomy, magnitude is used to measure the brightness of a star or another celestial object. The brighter it is, the lower the number assigned as a magnitude is. It's like golf, low scores, you know. In our case, it means that we'll be able to see the star with the unaided eye, even in light-polluted skies. Now, we can only see the binary with binoculars in a completely dark sky. After the outburst, T Coronae Borealis will remain the brightest star in the constellation of Coronae Borealis for a few days before gradually dimming. Now, this event shouldn't be confused with a supernova. In a supernova, a star's core collapses, which leads to its complete destruction. It can only happen to a star 8 times the mass of the Sun. Instead of disappearing in a blinding flash of light forever, T Coronae Borealis will experience a nova, an explosion on its surface, flinging matter into space but not ruining the star itself. Such recurrent novas happen at regular intervals. T T Coronae Borealis was known to astronomers from the past as the Blaze Star. Last time it exploded in 1866 and 1946. Astronomers from NASA believe it's going to do it again before September this year. The constellation of Coronae Borealis, also known as the Northern Crown, is one of the most beautiful out there. It's a curved semicircle of 7 stars, which is easy to find in April. You should go outside 2 hours after dark and look to the east-northeast. Once you find the Big Dipper, use the curve of its handle to go to Arcturus, finding the bright star in the Buddhist constellation due east. If you go diagonally down to the east-northeast horizon, you'll spot Coronae Borealis. Now, if you want to observe the brightening of T Coronae Borealis, it might be better if you get acquainted with the region and the stars of the constellation it's in. Once the event begins, you'll be able to compare its brightness against the other stars and observe the thing without using any fancy cameras. Now, a nova is a short-lived sudden explosion involving a compact star as large as Earth or a bit bigger. The outburst comes from a white dwarf circling remarkably close to a regular star, so close that a stream of gas flows between them. This gas starts piling up until it creates a layer on the white dwarf's surface, and then it reaches a point where it detonates in a runaway thermonuclear explosion. According to astronomers, around 50 nova happen every year in our galaxy, but not all of them are noticed. NASA's Fermi Gamma Ray Space Telescope has observed several nova that occurred not far on the scale of the universe. They found out that each blast produces gamma rays. Those are the most energetic forms of light. Researchers also think that these gamma rays result from collisions among numerous shock waves, racing from the explosion site in a quickly expanding shell of debris. Now, after we've talked about novae, it's time to discuss something much more dramatic: supernovae. It's the largest explosion humans have ever seen. Each blast is a super powerful burst of a star. One kind of supernova is caused by the last hurrah of an extinguishing massive star. It happens to stars at least 5 times the mass of our Sun. Once they near the end of their lives, they go out with a ginormous bang. Huge stars burn incredible amounts of nuclear fuel at their core, producing tons of energy. It makes their centers immensely hot. Heat generates pressure, and this pressure keeps such stars from collapsing. But any star is in balance between 2 opposite forces. Its gravity attempts to squeeze the star into a teeny tiny ball, and the nuclear fuel burning at the core of the star produces powerful outward pressure. Now, when a giant star is running out of fuel, it starts cooling off. Its pressure drops and gravity wins. The star collapses. An enormous object that is millions of times the mass of Earth collapses within 15 seconds. No wonder this brisk process produces enormous shock waves. It makes the outer layers of the star explode. Eventually, an incredibly dense core is all that is left behind, besides a growing cloud of hot gas called a nebula. A black hole, the densest object in the universe, is the result of a supernova of a star around 10 times as massive as our Sun. Also, there's another type of supernova. It usually happens in systems where 2 stars orbit each other, and at least one of these stars is a white dwarf the size of our planet. If such a star collides with another, or pulls too much matter from its neighbor, it can explode into a supernova. Also, supernovae are often so bright they can outshine the combined light of entire galaxies for several days or even months. Supernovae aren't common. Astronomers think just a few of them occur within the century in galaxies like our home Milky Way. But since the universe contains an enormous number of galaxies, we can observe a few hundred supernovae every year outside our galaxy. Unfortunately, space dust blocks our view of most supernovae happening within the Milky Way. Betelgeuse, a late-stage red giant, exploded in 2019, but it wasn't the event we expected to see. This star is found in the constellation of Orion and is huge, so big that if we moved it to the center of our solar system, its outer edge would go way beyond the orbit of Jupiter. When Betelgeuse eventually nears its end, it will explode in a stunningly bright supernova visible on Earth even during the day. This explosion could happen as soon as tomorrow or as far-flung as hundreds of thousands of years from now, so don't hold your breath. But then, what was it in 2019? Astronomers noticed that the star was dimming. They decided it was the initial stages of the grand show. But instead, Betelgeuse went back to normal over the course of the next few months. Further analysis revealed that the star hadn't dimmed. It just looked like that because we had been observing it through a cloud of stellar debris. At the same time, the amount of light in the photosphere of Betelgeuse ramped up. It was like a massive explosion of material from the surface of the star. Events like this occur on the Sun all the time, especially when our star's activity is high. Bits of the Sun's surface get tangled up and cast off. That's what we call coronal mass ejections. They don't harm our planet, but they can mess with satellites and electrical equipment. Now, getting back to Betelgeuse, we've never seen such a huge mass ejection on the surface of a star before. It's a new phenomenon which we can observe directly and even see surface details with the help of the Hubble telescope. Astronomers say we're watching stellar evolution as it happens for the first time.
Astronomers detected something strange happening in the darkness of space. They picked up a series of bizarre, unexplained signals coming from distant stars in the Ursa Major constellation. And literally no one can explain their origin. Is it some unknown natural phenomenon or something far more mysterious, more artificial? Let's explore this latest space discovery, the science behind these signals from space, and what scientists believe might be sending them. So, scientists picked up two identical bursts of energy coming from deep space. They weren't random and they weren't background noise. They seemed to be precise and even kind of purposeful. The signals came from the constellation Ursa Major. It lies about 100 light-years away from our planet. The star emitting those signals is called HD 89389. It's a little bigger and brighter than our Sun, but nothing too unusual. That is, until 2023. That's when NASA scientist Richard Stanton noticed something he'd never seen before. The star suddenly flashed, getting bright, then dim, then bright again, and it happened in just a few seconds. There were two identical pulses, exactly 4.4 seconds apart. According to Stanton, the star's behavior was beyond strange. The changes in brightness were far too powerful to be dismissed as random noise or the result of turbulence in Earth's atmosphere. A star over 1 million miles wide doesn't simply fade in and out like that. For a star to just blink out like that in 1/10 of a second is not the kind of thing science can explain easily. But it got even more curious. And the more scientists looked, the stranger it got. Apparently, this wasn't just a flicker, it was deliberate. It looked like something made that light change. But what could it be? It was a truly deep space mystery. So for the next 2 months, Stanton worked a lot. 1,500 hours of total observation time, checking every possible explanation. He compared the data to lightning strikes, airplane reflections, meteors, and even software malfunctions. And every single time, the result was the same. Nothing matched. That's when the research team had to admit what no one expected. Apparently, they couldn't rule out the possibility that those pulses might be artificial. The thing is, after checking every possible explanation, Stanton realized that their space telescope discovery wasn't something anyone had seen before. It couldn't be explained as static, it wasn't lightning, and it definitely wasn't a passenger plane flying by. But it reminded him of something. You see, back in 2019, astronomers detected another strange double pulse. This one was coming from a hot gas giant called Dimidium, about 50 light-years away from Earth. At first, experts laughed it off and blamed it on birds flying through the telescope's field of view. But the new signal didn't seem like one of those simple mix-ups. So, Stanton kept digging. He looked at everything and concluded that a shockwave in Earth's atmosphere could explain the signals. But that idea didn't quite fit. For all 3 pulses to sync up that perfectly, the timing would have had to be almost impossible. The researchers also looked into other possibilities. Maybe the light was bent by some far-off object in our solar system. Maybe a satellite or asteroid partially blocked it. Or maybe it was caused by refraction or even gravitational waves. But none of those theories really made sense either. Some details were clearly missing for astrophysicists to explain how a star could blink that fast and that cleanly. For now, Stanton believes the only way forward is to study all three known events more closely and see which explanations still hold up. You're probably asking yourself, how was this astronomy discovery even made? It started more than 60 years ago. That's when scientists officially kicked off the search for life beyond Earth. They called it the Search for Extraterrestrial Intelligence, or SETI. The pioneer of this undertaking was something called Project Ozma. It was led by astronomer Frank Drake, the same guy who came up with the famous Drake equation. This equation is a way for scientists to make an educated guess about how many worlds in our galaxy might have intelligent life that can send out signals we could detect. The idea is simple. You start with how many stars are born in our galaxy. Then you figure out how many of those stars have planets and how many of those planets could support life. Then you gotta figure out how many of those worlds might actually have living things and how many of those might develop intelligent beings. And finally, you try to calculate how many of those might build technology that could let them communicate with other civilizations, like ours. Now, the equation isn't really meant to give a clear number. It's more like a big thought experiment that helps scientists consider all those different pieces needed for life to exist and be noticed in the universe. Anyway, back in 1960, Drake and his team pointed a giant 82-foot radio dish at two nearby stars, Epsilon Eridani and Tau Ceti, and listened for anything unusual. Between April and July of that year, the observatory in West Virginia stayed tuned in, waiting for a signal from the stars. Unfortunately, nothing came through. But the project became the starting point of everything that came after. Since then, scientists have carried out dozens of similar searches using all kinds of wavelengths and technologies to find signs of intelligent life. These days, we call them technosignatures. And while no one's found solid proof yet, there have been a few moments where even experts couldn't rule out the possibility that something, or someone, might be out there. That's where Dr. Richard Stanton comes in and makes the shocking space discovery. Stanton is a NASA scientist who worked on some of the most iconic missions like Voyager and Grace. The latter was a project by NASA and the German Space Agency, where two satellites flew around Earth together, side by side. By watching how the distance between them changed, scientists could see how Earth's gravity shifted in different places. That helped them learn about things like melting ice, ocean movement, underground water, and even climate change. But after retiring, Stanton took on a personal project, searching for intelligent life from his own Shea Meadow Observatory in Big Bear, California. Using a custom-built telescope and a photometer he designed himself, Stanton spent years scanning more than 1,300 sun-like stars, not for radio signals from space, but for flashes of light. Unlike traditional SETI studies that focus on radio waves, Stanton's approach, called optical SETI, looks for laser-like pulses, sharp, quick bursts of light that could be used for communication across the stars. This idea actually goes back to the early 1960s, when two scientists suggested that advanced civilizations might use incredibly powerful nanosecond laser pulses to send visible signals that could outshine their own stars. For this study, Stanton didn't scan huge portions of the sky. Instead, he focused on one star at a time. He was staring at it for an hour straight and recording its light at incredibly tiny intervals, just 100 microseconds apart. That's fast enough to catch flashes less than a blink of an eye. Then he analyzed the data, searching for any strange repeating patterns and unexplained signals. And eventually, his efforts paid off, and he made the very space discovery we talked about. A sun-like star, about 100 light-years away in the constellation Ursa Major, sent two fast, identical pulses of light. So far, these signals remain unexplained. No one knows for sure what caused those perfect twin pulses. We can't even figure out how far away the source really was. Was something passing in front of the star? Or was the light itself being changed by something we don't understand yet? What we do know is that something strange is happening out there in Ursa Major. Maybe it's a new kind of cosmic event. Or maybe it's something else entirely. And one day, we'll crack this deep space mystery.
The Milky Way galaxy where we live looks like a ginormous pinwheel rotating in space. It's a spiral galaxy that appeared around 14 billion years ago. It's filled with a lot of stuff. Stars, nebulae, which are clouds of dust and gas, planets, asteroids, you and me and your parents and that messy kid down the street. You get the idea. And all these fans out from the center of the galaxy in long spiraling arms. A marvelous view. The Milky Way is about 100,000 light-years across, and it takes our sun, along with all the solar system, 250 million years to make one revolution around the center of our home galaxy. Wow, that's a big lap. Look at the sky at night, and most stars you'll see there would be located in just one of the Milky Way's arms. Before telescopes were invented, people couldn't see stars clearly. They blurred together into a single white streak, stretching across the sky. It looked like a river of milk. That's how the name of our galaxy appeared. Now let's get down to some recent and very exciting news. An international team of scientists has discovered something they've never seen before, hidden in the center of the Milky Way. It resembles Morse code. Is our galaxy trying to communicate with us? In the early 1980s, astronomers discovered giant one-dimensional filaments dangling vertically near Sagittarius A. That's our galaxy's central supermassive black hole. And recently, a new kind of such filament has been found. But they're much shorter and lie either horizontally or radially. In other words, they're spreading out like spokes on a wheel, going away from the black hole. Interestingly, even though both types of filaments do have certain similarities, researchers believe they most likely have different origins. The vertical filaments stretch through the galaxy, towering up to 150 light-years high, but the horizontal ones resemble the dashes and dots of Morse code. Scientists were beyond excited when they made this discovery, but they had to do a lot of research to make sure the structures indeed were what they look like. They managed to confirm that the filaments were not random, but tied to the outflow of the black hole. Thanks to them, it became possible to study the spin of the black hole and the orientation of its accretion disk, a rotating disk of matter formed around the black hole under the influence of its immense gravitational force. But let's have a closer look at the filaments we've been talking about. There are around 1,000 vertical ones. They appear in pairs and clusters and are often either equally spaced or side by side like strings of a harp. As for their horizontal counterparts, they seem to be around 6 million years old. Now, both the Milky Way, and it was unlike anything they'd seen before. This object released massive bursts of radio energy 3 times every hour, and even though there are other objects that switch on and off, for example pulsars, such frequent pulsation had never been observed before. Some astronomers admitted that this discovery was pretty spooky, since no known object in the sky could do it. Research teams started working on the discovery and found out that the object is likely to be 4,000 light-years away from Earth. It's also super bright and has an incredibly strong magnetic field. And still, if you do all the math, not me, you'll discover that it isn't supposed to have enough power to produce such radio waves every 20 minutes. The theories about the origin of this mysterious object vary. Some experts claim it could be an ultra-long period magnetar, whatever that is. Others think it might be a white dwarf or the remnants of a collapsed star. But it also might be something we've never heard about, an entirely new type of object. But one thing is clear. Astronomers managed to observe the signal across a wide range of frequencies, which means that it has a natural origin and it isn't something artificial. Now there's another mystery about the Milky Way. What can I say? It's a mysterious place. Around 15 years ago, astronomers launched the Fermi Gamma Ray Space Telescope. Gamma rays are an incredibly high-energy form of light. That's why when you observe the sky through the gamma ray telescope, rather than with your own eyes, the difference is dramatic. So, when astronomers started to use the telescope, they noticed that the center of our galaxy emitted much more gamma radiation than, for example, its outskirts. To put it simply, something is glowing incredibly brightly right in the middle of the Milky Way. But the most perplexing thing is that no one has been able to find a plausible explanation for this phenomenon for almost a decade. Some astronomers suggested that the central region of the Milky Way was glowing with such intensity because the dark matter was getting destroyed there. While no one has ever observed dark matter annihilation, scientists have been hypothesizing about this phenomenon for a long time. Naturally, we wouldn't be able to see dark matter itself, but the process could be producing the radiation the gamma ray telescope has spotted. That's how it could be happening. If particles of dark matter collided, just like ordinary matter particles do in particle accelerators, they would annihilate one another. As a result, they would burst into a shower of other particles, including the ones that make up gamma rays. But that's where the problem lies. If the mystifying glow was created by the annihilation of dark matter, then gamma ray particles would get distributed evenly in space. Instead, they gather together in clumps. That's why, to the great disappointment of numerous supporters, the theory based on the dark matter came up short. There is an alternative explanation of why the Milky Way is glowing. The culprit might be a group of millisecond pulsars, which are neutron stars spinning incredibly fast. And when I say fast, I mean about 1,000 times per second. The theory that the glow is caused by millisecond pulsars is quite plausible. As I've mentioned before, the light coming from there is clumpy rather than smooth, and it often happens when the source of light is one individual object, such as a pulsar. Several studies have concluded that due to the nature of the light, millisecond pulsars are the best explanation for this phenomenon. However, many scientists are still not persuaded. Those stubborn folk want proof, right? First of all, they state that the clumps of light may appear due to the interaction of gas between stars and cosmic rays. Besides, the pulsar theory has one more catch. Why would so many of them be clustered together in a perfect sphere around the center of the Milky Way?
Boom! It was an epic space explosion that made scientists' hair stand on end when they discovered it in February 2020. Its size and power are enormous, even by cosmic standards. We set our destination to a group of galaxies in the Giraffe constellation. If our rockets could fly at the speed of light, as fast as it takes the light from the bulb in your lamp to reach your eye when you switch it on, zoom, instant, It'd take 2.6 billion years to get where this explosion occurred in space. 2.6 billion years. A lot's happened in that time here on Earth. That long ago, dinosaurs weren't even around yet. Primordial life was just leaving the ocean and heading on land. Well, we're traveling faster than the speed of light, and we reach our destination, ground zero, for a boom so big, it'd be like 600 million suns exploding simultaneously. And our sun is massive to begin with. It could fit 1 million Earths inside. In fact, 99.8% of the stuff that makes up our entire solar system is the sun alone. The remaining 0.2% is all the planets, moons, asteroids, and other random cosmic bodies floating around our star. And here's the real kicker. This burst lasted 100 million years. That's from today's digital world with smartphones and self-driving cars, all the way back to dinosaur times. So what set off this space boom of epic proportions? A black hole. What else? This monster swallowed so much substance that it choked and shot out a bunch of plasma beams. They cut through space and formed a cosmic wasteland all around the site. It was thought to be the biggest explosion in the universe. But sooner or later, every record gets broken. We head to another galaxy cluster. This one, dubbed Ophiuchus. An explosion thundered in it 5 times more powerful than the one in the giraffe. It was so big, you could easily line 15 Milky Ways across its blast area. Mind you, our galaxy is over 100,000 light years across and home to 200 billion stars. Yeah, whoa is right. It was the largest space blast since the Big Bang that started it all 13.8 billion years ago. So what was the source of this blast? To answer that, we'll need a simple analogy. Just like on Earth, space sort of has its own megacities. These New Yorks and Tokyos of the cosmos are massive. And that word doesn't even do it justice, but I tried. They're officially called superclusters of galaxies. At the center of the most mega huge ones, you'll find a supermassive black hole. Now, scientists still don't know much about them, but the theory goes that they're essentially a whole bunch of stuff, or matter, that gets squeezed into a teeny tiny point that can't even be measured because it's infinitely small. Yeah, complicated stuff. Think of it this way. It'd be like taking the entire Earth and shrinking it down to the size of a grain of rice. That grain of rice would still weigh the same as the planet. All that stuff would just be really squished together. So more matter equals more gravity, meaning a black hole's pull is unescapably strong. Not even light can get past it, hence the whole black part of its name. Funny thing is, we can't even see them with our eyes. Black holes don't glow or reflect light. They just swallow it up like spaghetti. Ugh, makes me hungry just thinking about it. But back to epic space things that go boom. A supermassive black hole exploded in this Ophiuchus supercluster of galaxies. This monster stopped pulling in everything around it like black holes usually do. Quite the opposite. It started spewing stuff out. A colossal stream of plasma ripped through space almost at the speed of light and broke through a bubble 1.5 million light years across. Every thousandth of a second, it was like 20 billion megatons of TNT went off, and it continued doing that for 240 million years. But now, I draw your attention to the heavyweight of the Milky Way. It's the toughest guy in the galaxy, a supermassive black hole called Sagittarius A*. The mass of this beast is 4 million times that of the Sun. And you'll like this, it's only 25,000 light years from our home planet. In space terms, this thing is pretty much like our neighbor 2 houses down the street. Wait, don't worry, no need to pack up and move. Our neighbor has given up his old business of shooting hot jets into space. But in 2019, he did make astronomers' hearts skip a beat. Near this Sagittarius A*, they noticed a flash that was 75 times higher than normal. Their theories: 1. The hole swallowed up part of a star that found itself wandering way too close for comfort. Or 2. A gas cloud crashed into it. After a 14-hour spike in activity, Sagittarius A star finally calmed down. Phew! But in the past, this giant was quick-tempered and knew how to light space up. 3.5 million years ago, our very ancient ancestors, as in they weren't technically human yet, were already walking across Africa, innocently unaware of a cataclysm happening far off in the sky above them. It looked like a beacon that suddenly turned on and shot out 2 cone-shaped beams. The whole thing was triggered by a hydrogen cloud 100,000 times more massive than the Sun. It came too close, and Sagittarius A star reacted. Those jets of plasma cut through space for 200,000 light years. They didn't stop for another 300,000 years. That's the snap of a finger on the cosmic scale, but astronomers still find traces of that boom even today. Neutron stars also know how to set off some fierce fireworks. They appear after giant stars run out of fuel and collapse in on themselves. Imagine the entire sun getting squished down into the size of a small city. Yep, that makes neutron stars incredibly dense and heavy. 1 teaspoon of their matter weighs around 10 million tons. They spin extremely fast, hundreds of full rotations a second. And for some of them, they shoot out energy beams from the poles, making it look like a cosmic lighthouse. One of the most interesting neutron stars is in the constellation Sagittarius. Like black holes, it has powerful gravity and pulls in tons of matter. This all collects in a massive rotating disk. This particular one was powered by hydrogen from a nearby star. It gulped up its neighbor, taking in so much matter that it started heating up. The result? A gigantic fireball launched from its surface. Astronomers witnessed this on August 20th, 2019. They saw a 20-second flash that lit up space. It was the brightest burst NASA has ever seen. The star spent more energy on it than the sun produces in over a week. But of course, nothing beats the biggest boom of them all, the one that brought life to our entire universe, according to the most popular theory. But first, a little backstory. Scientists say only 5% of the universe is stars, planets, asteroids, comets, dust clouds, you, me, your chinchilla, all life, basically all the stuff you can see with your own eyes. So what can the remaining 95% be? The mysterious and dubious sounding dark energy and dark matter. In simple terms, they're like the yin and yang of space. Dark matter makes things attract to each other with gravity. It's the glue of our universe, keeping everything together. Dark energy does the opposite. It makes things repel and grow further apart. So the theory goes. And weirdly enough, dark energy makes things grow further apart the farther they are from each other. Scientists can even see this for themselves. The more distant a galaxy is, the more quickly it's moving away from Earth. But those two forces weren't always around. In fact, about 13.8 billion years ago, there wasn't anything around. Everything was condensed into a teeny tiny dot that's infinitely small. Sound familiar? Yep, this mysterious, forever shrinking point is also in the center of black holes, and it's called a singularity. It's where all our fancy science and math breaks down. It's the most puzzling thing out there. But one day, that incredibly dense and hot point started to expand in all directions, and it grew faster than the speed of light, doubling its size 100 times within a fraction of a second. If you want the specifics, it was 100th of a billionth of a trillionth of a second. Yeah. The more time passed, the faster and bigger it grew, and it's been expanding since, like blowing up a balloon that never pops. Scientists called this expansion the Big Bang.
Stargazers, come up here, because I have exciting news. Astronomers have just completed the full mapping of 2 pairs of stars outside our Milky Way galaxy that are chowing down on their stellar neighbors. Not only does it give us a better understanding of stars in general, but it can also help us measure distance in the night sky. Did you know that more than half of the stars in our Milky Way are paired? And while it's likely that other galaxies have a significant number of binary stars too, they're usually too faint to see. But these so-called symbiotic stars, where one star consumes the other, are extremely bright and easier to observe. And according to scientists, measuring the orbits of these symbiotic star systems is an essential step toward learning whether other galaxies create binary stars, like those in our Milky Way. Now, let's get down to the nitty-gritty. A pair of stars may be born together, but due to their masses, they age differently. The more massive one burns through its material faster, reaching the end of its lifetime first, and leaves behind a compact white dwarf. White dwarfs are small and dim, but can pack the mass of the sun into an object the size of Earth. If close enough, their gravity can pull material from their companion, creating a signal that astronomers can identify from far away. Draco, C1 and Lin 358 are the symbiotic stars that have been fully mapped. The stars in Draco C1 take roughly 3 Earth years to orbit one another, while Lin 358's components take just over 2. These are the first full orbital measurements of any symbiotic star system outside the Milky Way. The new measurements will help astronomers better understand star formation in other galaxies. In some symbiotic stars, the white dwarf can slurp enough material from its companion that it explodes in a supernova. These supernovae are incredibly bright and can be seen across the universe. They all start out with the same brightness for a nearby observer, making them like a sort of standard candle for measuring the universe. While Draco C1 and Lin 358 are unlikely to explode as supernovae anytime soon, understanding how they work can provide us with a better understanding of how these standard candles evolve. If you're here to complete your knowledge of weird stars in the universe, don't be disappointed. We're not finished just yet. Have you ever wondered about the biggest stars in the universe? Scientists have recently discovered a gigantic star called UY Scuti. This bad boy is located about 9,500 light-years away from Earth and is truly out of this world. It's about 1,100 times larger than our Sun, which means if it were in our solar system, it would reach past Jupiter's orbit. There's more. UY Scuti isn't just massive, it's also super bright. It's what scientists call a red supergiant, and it shines with a brightness of about 340,000 times that of our Sun. If you're thinking about getting a tan from this star, think again though, it's way too far away for that. How does a star like UY Scuti even form? You might wonder. Well, it starts out like any other star. A cloud of gas and dust collapses under its gravity and starts to heat up. Eventually, the temperature becomes hot enough in the core of the cloud to ignite nuclear fusion, and a star is born. But UY Scuti didn't stop there. It kept devouring more and more gas and dust, growing larger and larger. This process continued until it became the giant we know today. As fascinating as UY Scuti is, it's not the only big star out there. There are others like VY Canis Majoris, Canis Majoris, which was once thought to be the biggest star until UY Scuti stole the show. VY Canis Majoris is still a force to be reckoned with though. It's about 1,400 times larger than our Sun and located about 5,000 light-years away from us. But here's the kicker. Stars like UY Scuti and VY Canis Majoris aren't even the biggest things in the universe. Not by a long shot. There are objects called hypergiants that make these stars look like ants in comparison. One such hypergiant is Stephenson 218, located about 20,000 light-years away. It's about 2,150 times larger than our Sun and shines with the brightness of 7 million suns. And just when you thought things couldn't get any crazier, there's a mysterious object called the Great Attractor that's pulling everything in our local group of galaxies towards it. We don't know what it is or what's causing it, but one theory is that it's a massive cluster of hypergiants. We'd be minuscule in comparison. This next star is so metal, it's practically headbanging all the time. Jokes aside, scientists have discovered a star that's called a heavy metal subdwarf. It's a type of star that's seriously metal heavy. This star has more metal in its composition than any other star we've seen before. Such stars are said to contain metal elements like iron, nickel, and chromium. This heavy metal subdwarf has about 10,000 times more iron than our Sun. In their discovery, astronomers used a technique called spectroscopy, which involves analyzing the light that comes from the star to determine what elements it's made of. By looking at the spectrum of light, scientists were able to see that this star had an unusual amount of metal in its composition. There's more. This heavy metal subdwarf isn't just a regular star with a lot of metal, it's also really weird in other ways. For one thing, it's smaller and cooler than our Sun, and for another, it's really old. We're talking about a star that's been around for almost as long as the universe itself. What does this all mean? Well, scientists are hoping that by studying this heavy metal subdwarf, they can learn more about the early universe. Since this star is so old that it was around when the universe was just beginning to form, it's seen a lot of stuff. By studying its composition and characteristics, scientists can get a better understanding of what the universe was like in its early days. This next star is one of the coolest things in outer space. Her name is Vega, and it's one of the brightest stars in the night sky. Some recognize it as the shiny point of light in the constellation Lyra-Lyru. And get this, it's only about 25 light-years away from us, which in astronomical terms is practically next door. Scientists have been studying Vega for a long time, and they've learned some pretty interesting things. For starters, Vega is a young star, only a few 100 million years old. That might sound like a long time, but compared to our Sun, which is around 4.6 billion years old, Vega is practically a newborn. Vega is also a very hot star, with a surface temperature of around 9,400 degrees Celsius F. To put that into perspective, the surface of our Sun is only about 5,500 degrees Celsius. So, if you think it's hot outside today, just be glad you're not hanging out on Vega. Another interesting thing about this star is that it's surrounded by a disk of dust and gas. This disk is called a debris disk because it's made up of leftover material from when the star formed. Scientists think that this debris disk is similar to the one that surrounded our solar system when it was young. Vega is also a source of cosmic rays. These rays are high-energy particles that zip around space at incredible speeds. They're made up of protons, electrons, and other particles, and scientists aren't exactly sure where they come from. But they do know that Vega is one of the places where cosmic rays originate. But wait, there's more. Vega is also a famous star in pop culture. It's been used in a lot of movies and books as a source of inspiration, mostly because of its brightness and cool features. Now, I'll bet you remember the furthest planet from the Sun is Neptune. When European astronomers argued about what to call a newly discovered eighth planet back in 1846, they settled on the name of the Roman deity of the sea. This ice giant is 4 times the size of Earth, and if our planet was the size of a nickel, Neptune would be as large as a baseball. At the same time, the ice giant is 17 times as heavy. If you were approaching this icy world, it would seem blue, and perhaps inviting. But this blue surface is actually a layer of swirling gas and permanent clouds. So don't get your hopes up. You wouldn't be able to land on this planet. Its mantle, made up of water, ammonia, and methane ice, is the closest thing Neptune has to a surface. But even down there isn't solid ground for you to walk on. Anyway, this distant planet is surrounded by mystery, and astronomers haven't cracked all of it yet. Why are the winds on Neptune so fast? Why does this world shed more heat than it gets? Why is its magnetic field offset? And what is the Great Dark Spot? Let's try to find some answers. Neptune is around 30 times as far from the Sun as our home planet. It explains why studying this distant world is so difficult. It also means that the planet gets way less light and heat from our star. But at the same time, Neptune radiates a lot more heat than it's taking. If we compare Neptune to nearby Uranus, we'll see that even though Uranus is closer to the Sun, it emits almost the same amount of heat as Neptune. Astronomers don't know for sure why it happens yet, but of course, there are theories because they're scientists. Some experts think there is something fierce inside the blue planet that causes it to generate more heat than it gets. It might be the reason for Neptune's huge differences in temperatures, from 160 degrees Celsius at the planet's frigid cloud tops to more than 6,650 degrees Celsius at the core of the ice giant. So you're going to want to dress in layers. Such temperature variations might be the reason for powerful windstorms. Their speed can reach 1,130 kilometers per hour. For comparison, the most powerful winds on Earth move at a speed of 400 kilometers per hour. Another curious thing about Neptune's winds is that they are blowing westward, which is backward to the rotation of the planet. A study published in 2013 supposed that the winds on Neptune would appear in thin layers no more than 960 kilometers thick. Such a shallow depth might mean that condensing and evaporating moisture could produce those crazily fast air currents. Then there's the issue of Neptune's magnetic field being offset. If you were to overlay a magnet on this planet, it wouldn't line up with the center. Astronomers aren't sure why it happens. Magnetic fields are produced by moving currents, and all the planets, including Earth, are believed to have some conductive material moving in their bellies. But with Neptune's belly, it's a bit different. Its magnetic field is tilted at 47 degrees to the planet's rotation, which means that the rotation and magnetism aren't aligned inherently. And don't forget about the Great Dark Spot. No, I'm not talking about the most massive storm in the solar system. That one is called the Great Red Spot and is located on Jupiter. I mean a corresponding spot on Neptune discovered by Voyager 2 in 1989. In 1995, the Hubble Space Telescope turned its eye to Neptune, but disappointingly, by that time, the spot had already mysteriously vanished, and scientists have no idea how exactly it disappeared. But guess what? Another dark spot has been found on the ice giant. Astronomers have known for quite some time that from time to time, Neptune's surface gets dotted with such dark spots. These bizarre discolorations have been linked to high-pressure areas, coming and going over the course of a few years, but no one has seen a dark spot forming until recently. Since then, astronomers have been observing the birth of dark spots quite regularly. Now they have a much better idea of where and when these huge vortices might form. Despite assumption CC, astronomers once thought Neptune was a boring, featureless world. The ice giant has a hyperactive atmosphere. It's turbulent, with cloud ripples and severe storms. Plus, this planet has a ring system. Disappointingly, those rings are not distinct hula hoops circling Neptune, like those of Saturn. The ice giant's rings are weirdly chunky and contain gobs of material that form arcs in the outer ring. Astronomers explain that these clumps are actually places where loads of ring particles are stuck together. What it means is still unclear. But my favorite thing about Neptune is this one. Astronomers believe that deep inside the planet, there might be a layer where it rains diamond crystals. Intense pressure and temperature inside Neptune break methane molecules apart, releasing carbon. These carbon compounds find their fellow molecules and create long chains, which then get squeezed together, forming beautiful crystalline patterns, like diamonds. When these diamond formations drop through the layers of Neptune's mantle, it gets too hot for them. That's why they vaporize, float back, and, you guessed it, repeat the cycle. Now you know why it's called diamond rain. How about a little fun experiment? Let's say we exploded Neptune, in the name of science, of course. As you already know, this planet doesn't have a solid surface. That's why after activating the process, you'd see Neptune's liquid mantle burst. It would look like a water-filled balloon thrown down from the 50th floor. Disclaimer, don't do this at home. The impact would send splashes of water, ammonia, and methane ice away into space. It'd be followed by lava-like remains of the planet's mantle, liquid and red hot. And then there would be a hurricane of solid rocks. That's what would be left from Neptune's solid core, made up of iron and other metals. Okay, now let's put this pretty ice giant back together. I've got one more experiment for you. Let's replace the moon, yes, our good old satellite, with Neptune. The ice giant is definitely way larger than the moon. The planet would look like a bright blue hot air balloon in the sky, and we would see it not only at night, but also during the day. It would appear to be 15 times larger than the sun. If everything else remained the same, solar eclipses would seem to continue for ages. Once the sun vanished behind Neptune's edge, our planet would be plunged into complete darkness for no less than an hour and a half. And since Neptune is also much more massive than Earth, its gravitational pull is much stronger. That's why instead of getting itself a powerful companion and protector, our planet would end up as a satellite. Yep, Neptune's moon. It would orbit Neptune slightly further than its own largest moon, Triton. And there would be a great risk of Earth colliding with this space body. But let's assume we were lucky enough not to cross paths with any of Neptune's satellites. Even so, we would have more than enough problems. Tides on our planet would become 1,000 times more powerful than those caused by the moon. Neptune's gravitational force wouldn't pull Earth apart, but it would heat our planet up. Like we need more of that, huh? The seismic activity would increase, setting off earthquakes and volcanic eruptions. Well, it sounds unsettling, so let Neptune remain where it is now. I'm okay with the good old moon. Now, we're done with experiments, but hear me out. Beyond the orbit of Neptune, there is a mysterious Kuiper belt filled with massive icy objects. The most curious thing about this space formation, though, is that scientists fail to explain the pattern of its movement. The only explanation they have is that Neptune might be hiding another big planet from our sight. Are they in cahoots? This hypothetical planet has already got the name Planet 9, and all we have to do is wait until its existence is confirmed. Or not.
Now, it's been a long time since there was a supernova in the Milky Way. Over 400 years to be precise. So hey, we're long overdue. So here are the most likely stars to go boom, if they haven't already. At the top of the list must be the southern hemisphere star Eta Carinae. Greek letters before the name of the constellation indicate the rank of the star's brightness in that constellation. Sir Edmund Halley, in 1677, recorded Eta Carinae as the seventh brightest star in the constellation Carina, Eta being the seventh letter in the Greek alphabet. It might not have looked very bright to Sir Edmund and his contemporaries in the 17th century, but modern studies of Eta Carinae estimate it's 5 million times more luminous than our Sun. Luminous is a technical word astronomers use. It doesn't just mean brightness. Luminosity refers to the total energy released at all frequencies. Eta Carinae releases 5 million times more energy than the Sun. Truly one of the whoppers of the Milky Way, Eta Carinae is 100 times more massive and 240 times larger than our yellow-white dwarf sun, Sol. Obviously, since it appears dim, Eta Carinae is pretty far away, about 7,500 light-years away. Yet even at this distance, if this star goes hypernova, it can still impact Earth's ozone layer, disrupt satellite communications, and harm astronauts. 159 years after Halley's observation, Eta Carinae experienced a nova-like explosion. It increased from a relatively dim star to become the second brightest star visible from Earth, but only for a period of 27 years. From 1836 until 1863, Eta Carinae was the second brightest visible star after Sirius, the dog star, and Sirius is only about 8 light-years away. Since 1863, aside from a couple of flare-ups, Eta Carinae has dimmed back down to its original brightness at magnitude 4.5. Now, astronomers owe us a small apology, which we don't expect to get anytime soon, for star magnitude nomenclature. The brighter a star is, or planet, or moon, the lower its magnitude. Thus, stars brighter than first magnitude are either zero magnitude or negative magnitude. The full moon, for example, is magnitude negative 13. A magnitude positive 4.5 star, like Eta Carinae, is quite dim as seen from Earth, but it's clearly visible in a night sky without light pollution or clouds if you live anywhere south of the latitude of Cairo, Egypt. 30 degrees north latitude is the farthest north you can see this star. Now, listen up. Eta Carinae is currently up to something. It's been brightening again and is now brighter than at any time since 1864. It's a complex situation. Eta Carinae is really 2 stars, Eta Carinae A and Eta Carinae, what's your guess? Oh, B. There's a third star nearby that's also interacting with the double star's dynamics. Now, without looking, I'm guessing it's named Eta Carinae C. Good guess. Blown out into 2 incredibly massive globes of gas that are expanding at 20 million miles per hour, Eta Carinae is, without a doubt, one of the strangest looking stars you'll ever see. Remember, it's located at a great distance of 7,500 light-years away from us. And if anything had happened to Eta Carinae in the last 7,500 years, like going hypernova, we wouldn't be able to see it, because none of Eta Carinae's electromagnetic radiation would have gotten here yet. Astronomers are keeping a close watch on Eta Carinae because it can go hypernova at any time. Or maybe it already did 5,000 years ago, in which case we'd only have to wait another 2,500 years to see it. Yeah, like I'll put it in my planner. Now, from a list of over 30 likely candidate stars that might go supernova, Rho Cassiopeiae is many astronomers' choice. Another Greek letter, Rho, is the 17th letter in the Greek alphabet. It means that Rho Cassiopeiae is the star with the 17th brightest apparent magnitude in the constellation Cassiopeia. Yet Rho Cass, a nickname, is only one of 7 known yellow hypergiant stars in the Milky Way. It's another whopper. To be seen at magnitude 4.5 from a distance of about 10,000 light-years away, Rho Cass must be a very large star, a hypergiant. Placed where the Sun is, Rho Cass would encompass the orbit of Mars. But it's still yellow. It's not a red giant star. Red indicates a cooler surface temperature. Rho Cass, as huge as it is still as hot on its surface as our Sun, or even a little hotter. That can only mean 2 things. Deep inside its core, Rho Cass is fusing atoms much heavier than hydrogen or helium. Plus, Rho Cass is producing much more energy than a red giant star. In the year 2000, Rho Cass erupted massively. It brightened by 2 orders of magnitude as it ejected 10,000 times the mass of Earth into space at 4 times the speed of sound. Astronomers detected the signature of titanium oxide in this eruption. This means that Rho Cass is much closer to going supernova, or in this particular case, hypernova, than astronomers used to assume. Iron is just a few steps above titanium in the periodic table, and when iron forms, fusion stops and a star collapses. Rho Cass is really close, or more correctly, was really close, because the eruption we saw in the year 2000 really happened 10,000 years before. Many astronomers think Rho Cass has already gone hypernova, formed a black hole, and doesn't even exist anymore. Meanwhile, Betelgeuse caught everyone's attention not so long ago. The star, not the movie. It dimmed dramatically, appearing only 37% as bright as it usually is. Is it getting ready to go supernova? Betelgeuse is by far the brightest star in the whole sky, in infrared light. This is an important fact because it relates to Betelgeuse's status as a supernova candidate, as we shall soon see. Betelgeuse is also named Alpha Orionis, another Greek letter designation. So we should conclude that Betelgeuse is the brightest star in Orion, right? Wrong. It's the second brightest star in its constellation. Rigel, or Beta Orionis, is the brightest one in that region. Yeah, figure that one out. It may be because Betelgeuse is classified as a semi-regular variable star, which sounds kind of redundant to me. Its approximately 400-day cycle of pulsation changes its brightness by about 1 full magnitude, going from much brighter than a first magnitude star to closer to a second magnitude star. But never was Betelgeuse observed to dim so rapidly or so drastically as it did recently. So what's going on with it? Well, from late 2019 to mid-2020, Betelgeuse went through a period of substantial dimming during a mass ejection event. The world astronomy community jumped on the situation, and in the course of their investigations, they came up with some surprising new factual data on Betelgeuse. First, Betelgeuse is not as far away as we once thought. The new, more accurate distance for Betelgeuse is 548 light-years. That's 25% closer than previously measured. The second new fact, Betelgeuse's diameter has been reduced by the same percentage. The star is now known to be 25% smaller than previously believed. The cause of Betelgeuse's dramatic dimming was also determined. The giant star ejected a cloud of gas that contained magnesium. The cloud blocked a large portion of the light coming from Betelgeuse and made it appear visually much dimmer than it really was. Magnesium is not halfway to iron on the periodic table, which means Betelgeuse is not as far along on the path to a supernova as was suspected previously. When iron starts forming in the star, it means that this star is close to shutting down its fusion reactions. The next step is implosion. We aren't quite there yet with Betelgeuse. This star emits most of its energy as infrared light, and it also indicates that its core is most probably still burning helium, and not something that would greatly increase the amount of heat, like carbon for instance. Betelgeuse will still go supernova, but not for another 100,000 years. So you can cross it off your supernova list for the time being. And as for how to correctly pronounce Betelgeuse, you can say it any way you like. There are as many different pronunciations out there as there are people who think they know how to pronounce it correctly. Now, supernova 1987A caught astronomers off guard when it lit up the Large Magellanic Cloud 100,000 plus light-years away from the Milky Way. That's when attention was turned to a similar star much closer to Earth, Rigel, in the constellation of Orion. Could Rigel surprise us and suddenly go supernova? There's something called the supernova problem that you should, probably know about because it may relate to Rigel going supernova or not. It seems that stars over 17 solar masses don't always go supernova. Recently, a red giant star simply vanished. Once again, it didn't go supernova, it disappeared. This had often been happening in computer simulations of supernovae, and now it finally occurred in real life. Rigel's mass is 21 solar masses. In other words, it's 21 times more massive than our Sun. So, will Rigel go supernova or simply vanish into a black hole that it'll create in its core? Astronomers and physicists continue their work of learning more about the dynamics of massive stars, scouring the sky for the next supernova in the Milky Way. Meanwhile, we can rest confident that we on Earth are in no danger from the harmful effects of nearby supernova explosions. We live in a nice, quiet, peaceful stellar neighborhood, except for those Martians next door.
Buckle up, fellow space enthusiasts, because we're about to uncover the celestial secrets that have been unveiled this year. From giant stars to organic molecules, this year is going great for astronomers. So let's catch up on all the excitement you might have missed in 2023. First of all, we've discovered some real astral monsters. Imagine looking up at the night sky and seeing stars that are not just big, but absolutely enormous. Scientists have been using a special telescope called the James Webb Space Telescope to explore the early days of the universe. And during their adventure, scientists stumbled upon ancient stars that are 10,000 times bigger than our Sun. Yes, you heard it right, 10,000 times. These giants of the stellar world were some of the very first stars ever to form in the universe, billions of years ago. Imagine a globular cluster as a massive cosmic crew, where each group consists of a whopping 100,000 to 1 million members. These clusters are like giant family gatherings, with all the stars being born around the same time. But what makes these newly discovered monsters so special? Well, their cores, or their central parts, are way hotter than what we see in stars today. Scientists think that this intense heat might be due to a lot of hydrogen burning at really high temperatures. It's like they're having a galactic barbecue party. Something fascinating happens in these globular clusters. The smaller stars crash into the supermassive ones and gain extra energy, like a power-up. But here's the twist. Most of these clusters are now getting old, and the supermassive stars disappeared a long time ago. We can only see hints of their existence in the clusters we observe today. Scientists studied them by just the mysterious traces of their grand presence. The discovery of these monster stars is incredibly important for our understanding of the universe. If scientists can gather more evidence to confirm their existence, it would be a major breakthrough. It would help us learn more about globular clusters and how supermassive stars form in general. But that was only the first fascinating discovery of 2023. Although the next one is kinda sad. You know those beautiful rings that make Saturn look so fancy? Well, guess what? They might disappear in the not-so-distant future, astronomically speaking. NASA's Cassini mission, which explored Saturn from 2004 to 2017, gathered some fascinating data about the rings. During Cassini's grand finale, when it did some cool maneuvers between Saturn, scientists noticed something surprising. The rings were losing a lot of mass every second, tons of it. That means this magnificent halo will only stick around for a few 100 million more years at most. That may seem like a long time for humans, but in the grand scheme of the universe, it's just a blink of an eye. The important thing is that we've learned that huge rings like Saturn's don't last forever. They eventually fade away. Well, at least you and I personally won't catch this moment. Scientists have a fun theory about what will happen when Saturn's rings disappear. They think that the other ice and gas giants in our solar system, like Uranus and Jupiter, might have once had massive rings too. But over time, those rings wore down and became more like the thin, wispy bands of asteroids like what Uranus has now. Saturn's rings are mostly made of ice, but they also have a sprinkling of rocky dust. This dust comes from asteroids and teeny tiny meteoroids, crashing into the celestial objects and breaking apart. It's like a snowstorm of icy particles and space debris. The research also revealed that Saturn's rings appeared long after the planet itself formed. They were still forming when dinosaurs roamed the Earth. So, in terms of astronomical age, they're actually quite young, only a few 100 million years old. This discovery has got scientists all excited because it means something dramatic happened in Saturn's past to create this stunning icy disk. But this is a mystery waiting to be solved. Scientists want to figure out what exactly caused the rings to form and why they have such a breathtaking structure. Let's hope they'll figure it out. But moving on to something more optimistic, we have another exciting space news. Recently, scientists have been studying one of the most distant galaxies in the universe, and they found something amazing: organic molecules. The galaxy in question has a long name SPT044847. It's over 12 billion light-years away from our little blue planet. Can you even imagine that distance? It's the farthest galaxy ever known where complex organic molecules have been found. That's why looking at this galaxy is like looking at something from when the universe was just a baby. We have no idea what this galaxy looks like now. The light that has reached us is what it looked like when the universe was only 1.5 billion years old. Imagine being able to see things from so far in the past. So, what they found is something with a very complicated name: a polycyclic aromatic hydrocarbon molecule, or simply PAH molecule. You might be wondering, what in the world is that? Well, guess what? You can actually find these molecules right here on our planet. They can be in things like the smoke from car engines or even forest fires. Pa molecules are made up of chains of carbon atoms, and here's the super cool part. They're considered the basic building blocks for life. Imagine that. Life's building blocks, those tiny carbon chains, being discovered in a galaxy that's so far away. That's like finding a needle in a haystack. They also found out that gas floating around in that galaxy is filled with heavy elements. That's a big deal, because it suggests that many stars have come and gone there, creating all these amazing elements. This means that this galaxy can be potentially rich in many other elements too. This discovery opens up a world of possibilities and raises so many exciting questions. How did these molecules form in a galaxy so distant? And since we're looking into the past, what could have happened to these organic molecules during this time? Could they have evolved into life? We're only scratching the surface of the incredible things waiting to be uncovered. By the way, if it's so far, how did scientists even manage to discover something like that? Well, they had the instrument called the James Webb Space Telescope. This fancy telescope was recently launched and has superpowers when it comes to observing the universe. So, when the scientists were studying this faraway galaxy, they had a little problem. The light coming from those distant objects was so faint that it was hard to see or detect. But guess what? They had a brilliant idea to solve this. They used something called gravitational lensing, which is like a special power of nature's magnifying glass. Imagine two galaxies lining up perfectly, just like in a photo shoot. The light from the faraway galaxy, the background one, travels towards us. But on its journey, it passes through the foreground galaxy, which is like a giant space lens. And guess what? The foreground galaxy's gravity bends the light, just like a magnifying glass, making it bigger and brighter. It's like having a cosmic zoom lens for our telescopes. This bending of light creates a super cool shape called an Einstein ring. It's like a halo or a ring of light surrounding the foreground galaxy. Basically a nature's way of showing off its magical powers. With gravitational lensing and these beautiful Einstein rings, scientists can see distant objects more clearly and learn amazing things about the universe. And thanks to all that, they managed to uncover the hidden chemical interactions from the early galaxies. Isn't that incredible? The scientists are beyond excited about this discovery. They never expected to find such complex organic molecules in a galaxy that's incredibly distant. Who knows? Maybe this is just the beginning of a thrilling cosmic journey. So, keep your eyes on the stars, fellow space explorers. The universe is full of surprises, and who knows what other mind-blowing discoveries await us out there. Let's hope we'll learn even more in the future.